topic of discussion is alkynes. Let's do some multiple choice questions based on alkynes. Question number 1. Chain and position isomers of alkynes start from. First option pentyne, second option butene, third option propyne, and fourth option is ethyne. We have to find out from which alkyne the chain and position isomerism start. Actually, position isomerism starts from butene onwards. You can have 1 butene and 2 butene, but chain isomerism you should have minimum 5 carbons. I will show you. This is pentyne, this is pentyne, and its chain isomer can be written like this: CH3 CH CH3 C triple bond CH. So these two are a pair of chain isomers, whereas its position isomer can be written like this. While this is 1 pentyne, this is 2 pentyne, these two are related. See, I'll number them as 1, 2, 3. 1 and 2 are related to each other as chain isomers, and 1 and 3 are related to each other as position isomers. Even 2 and 3 are chain isomers. So you should have minimum 5 carbons. So the correct answer is first option, that is pentyne. From pentyne onwards, it is possible to have both chain isomerism as well as position isomerism in alkynes. Question number 2. In Kolb's electrolysis for the preparation of ethyne, the electrolyte is first option sodium fumarate, second option sodium succinate, third option sodium acetate, and fourth option is sodium ethoxide. See, the correct answer is sodium fumarate. I am going to write the structure of sodium fumarate. This is the triple bond, and you have COO-Na. Sorry, there is a double bond actually. This is sodium fumarate. When it undergoes electrolysis, it will produce HC triple bond CH, 2 moles of carbon dioxide, 2 moles of NaOH left out in the solution, and hydrogen gas is produced. So this is the product which is obtained. Ethyne is prepared by electrolysis of sodium fumarate. This is sodium fumarate. Whereas sodium succinate gives ethene, sodium acetate will give ethane on electrolysis, Kolb's electrolysis. So question number 3. Hydrolysis of which one of the following carbides liberates ethyne? First option calcium carbide, second option beryllium carbide, third option aluminum carbide, and fourth option is methane. Let's check it out. Calcium carbide on hydrolysis produces calcium hydroxide and acetylene, that is ethyne. Beryllium carbide on hydrolysis produces beryllium hydroxide and methane. Aluminum carbide on hydrolysis produces aluminum hydroxide and methane. The last option CH4 does not undergo hydrolysis. So the question is hydrolysis of which one of the following carbides liberates ethyne? The correct answer is first option CaC2. Calcium carbide on hydrolysis produces ethyne. This is ethyne. Question number 4. The question is regarding this. The equation given is 1,2-dibromoethane. This is 1,2-dibromoethane. It is being treated with alcoholic KH. When you do this, it will undergo dehydrohalogenation and you end up with CH2 CHBr, you get CH2 CHBr. H and Br are lost from adjacent carbon atoms. Then it is being treated with soda amide. Then it will lose another mole of HBr, and this time you get acetylene. So the question is regarding X and Y. So X is vinyl bromide and Y is acetylene. This is acetylene and this is vinyl bromide. So the correct answer is third option, vinyl bromide and acetylene. Question number 5. The equation given is propine is being treated with 2 moles of HBr and we need to find out major and minor products. Propine, we are adding to propine, we are adding 2 moles of HBr and we are asked to find out major and minor product. One product which is expected to form is this one. This is Markovnikov product, and apart from this you also get CH3, CH2, CHBr2. This is 1,1-dibromo and this is 2,2-dibromopropane. So the correct answer is second option, 2,2-dibromopropane is the major product and 1,1-dibromopropane is the minor anti-Markovnikov product. This is minor and this is major. 2,2-dibromopropane is major, 1,1-dibromopropane is minor. 1,1-dibromopropane, whereas this is 2,2-dibromopropane. So the correct answer is second option. Question number 6. Propine is treated with water in presence of mercuric ions and acidic conditions and the product formed is X. We need to identify X. First option is acetaldehyde, second option is propionaldehyde, third option is propanol and fourth option is propanol. Let's write the equation. This is propine. We are adding water in presence of mercuric ion and acidic conditions. So propine, we are adding water in presence of mercuric ion and H plus. We initially get propanol. This is due to Markovnikov addition of water. Then this will undergo tautomerism. Then you end up with CH3, C double bond O, CH3. This can be called as propanone or acetone. So the correct answer is fourth option. Question number 7. Ethyne is treated with HCN in presence of barium cyanide and then the product formed X is subjected to polymerization and we have to find out X and Y. The first option is vinyl cyanide and polyvinyl alcohol. Second option is allyl cyanide and PVC. PVC stands for polyvinyl chloride. And then third option is vinyl cyanide and orlon. Fourth option is vinyl cyanide and polythene. Let's try to find out. HC triple bond CH plus HCN. You get CH2 double bond CHCN. This is called as vinyl cyanide. When vinyl cyanide undergoes polymerization, this is vinyl cyanide. On polymerization, you get this CH2 CHCN taken n times. This is called as Orlon. So the correct answer is third option. The first step you get vinyl cyanide, and on polymerization you get Orlon, polyvinyl cyanide. Question number 8. Acetylene upon oxidative ozonolysis gives. First option acetic acid, second option formic acid, third option glycolic acid, and fourth option is C2H4 ethylene. So the correct answer is, look at the equation. Acetylene is subjected to oxidative ozonolysis. You get 2 moles of formic acid. So the correct answer is second option, formic acid. Question number 9. Bayer's reagent is decolorized by acetylene due to formation of first option oxalic acid, second option acetic acid, third option ethene, and fourth option is propionic acid. This is acetylene. It is being treated with cold dilute alkaline KMnO4. This is called as Bayer's reagent. It's an oxidizing agent, and it oxidizes as KMnO4 brings about cis hydroxylation, and because you have 2 pi bonds, it takes place 2 times and you end up with oxalic acid. So the correct answer is first option, oxalic acid. Question number 10. Acetylene is oxidized by acidified dichromate to form. First option formic acid, second option acetic acid, third option glyoxal, and fourth option is oxalic acid. This reaction, acetic acid with K2Cr2O7 potassium dichromate, will give acetic acid. It's an oxidation reaction. Acetylene is oxidized to acetic acid. So the correct answer is second option, acetic acid. Question number 11. Acidic nature of hydrocarbons is in, you have different orders of ethane, ethene, and ethane. You can see first option is ethane greater than ethene greater than ethine. Second option is ethine greater than ethene greater than ethane. Then you have ethene greater than ethine then ethane. Then you have methane, acetylene, and ethylene. See, acidic nature depends upon the electronegativity of carbon to which hydrogen is attached, and electronegativity is highest when the hybridization is sp. So order of electronegativity of various types of carbons is sp greater than sp2 greater than sp3. A highly electronegative sp carbon can stabilize negative charge more efficiently. This negative charge generates due to loss of H as H plus. So the correct answer therefore is second option, ethyne greater than ethene greater than ethane. So second option is the correct answer, and reason is greater electronegativity of sp carbon when compared to sp2, and sp2 is more electronegative than sp3. Question number 12. Order of reactivity towards electrophilic addition is first option alkynes greater than alkenes greater than alkanes. Second option is alkanes greater than alkenes greater than alkynes. Third option is alkenes greater than alkynes greater than alkanes, and fourth option is alkenes is equal to alkynes, then this is greater than alkanes. Actually the correct answer is third option, alkenes greater than alkynes greater than alkanes. Look at this. Let us compare the two cases of alkene and alkyne. Alkanes is ruled out because they do not have unsaturation, so they cannot undergo addition reaction. So alkanes are ruled out. The comparison should be made between alkyne and alkene. These carbons are more electronegative than sp2 carbons. This is sp2 carbon, this is an sp carbon. So sp carbons being more electronegative, they attract the electron cloud due to pi bonds more strongly, and they decrease the nucleophilicity of triple bond, and that is the reason why alkynes are less reactive than alkenes. So, the correct answer is third option, alkenes are greater than alkynes, alkynes are greater than alkenes. Question number 13. Reagents used to distinguish acetylene and ethylene are A. Tollens reagent, B. Ammonical cuprous chloride, C. Sodamide, and D. Alcoholic KOH. The correct answer is first option AB, second option BC, third option AC, and fourth option ABC. Actually, the correct answer is first option AB, because alkynes give white precipitate with Tollens reagent and red precipitate with ammonical cuprous chloride. Alkenes do not respond to these two tests. Look at the equation. Consider acetylene. This is Tollens reagent, ammonical silver nitrate. This is Tollens reagent, and you get silver acetylide, which appears as a white precipitate. Similarly, acetylene reacts with ammonical cuprous chloride, and you get a red precipitate due to cuprous acetylide. These two reactions are not given by alkenes. So, you can distinguish between acetylene and ethene by these two tests. So, the correct answer is first option AB. Question number 14. Hydrolysis of these carbides produce alkynes. A. Calcium carbide, B. Magnesium carbide, C. Aluminum carbide, and D. Beryllium carbide. Let us write the equations. Calcium carbide on hydrolysis gives acetylene. Magnesium carbide on hydrolysis gives propyne. Aluminum carbide on hydrolysis gives methane. Beryllium carbide also gives methane. The question is, hydrolysis of these carbides produce alkynes. So, the correct answer is CaC2 and Mg2C3. So, the option is second option AB, magnesium carbide and calcium carbide, AB. So, second option is the correct answer. Question number 15. Assertion is, in unsaturated hydrocarbons, terminal alkynes exhibit more acidic nature. Reason given is, increased S character of sp hybrid orbitals makes a sp hybrid orbital sp hybrid carbon more electronegative. It is a fact actually. Sp hybrid orbital, due to greater percentage of S character, it is smaller in size. Because of small size, it is more electronegative. Because it is more electronegative, it is capable of stabilizing negative charge, which is formed as a result of loss of H as H plus. So, the correct answer therefore is first option. Question number 16. Acetylene forms a red precipitate with ammonical cuprous chloride, and the reason given is acetylene forms Cu2O with ammonical cuprous chloride. Actually, the reason given is not correct. The type of reaction which takes place is acetylene, when it reacts with cuprous chloride Cu2Cl2 in presence of ammonium hydroxide, it forms cuprous acetylide. This is responsible for red precipitate. It is not due to Cu2O. Cu2O formation does not take place here. So, the correct answer therefore is third option. A is true, but R is not true. Question number 17. Some reactions are given in the list 1 and we need to match them with the list 2 compounds given in the list 2. First reaction is heating of 2,3-dibromobutane with excess of alcoholic KOH. This is 2,3-dibromobutane and you are treating it with excess of alcoholic KOH. Dehydrohalogenation takes place and you end up with 2-butyne. So A should be matched with the first option in the list 2. And then heating the iodoform with silver powder. When you do this, you get 6 moles of AgI and acetylene. So B should be matched with 3 ethyne. Next, reaction C is heating 1122 tetrabromopropane with zinc dust. This is 1122 tetrabromopropane and you are heating it with zinc dust. Zinc bromide is lost and you get propyne. So C should be matched with 2. And the last one, propyne is subjected to hydration in presence of mercuric ion and H plus, you get propanone. So D should be matched with 4. Therefore, correct answer is first option. Question number 18. X is treated with alcoholic KOH to give Y. Y is treated with red hot tube to get benzene. What is X? We have to find out. Look at the options. First option is 1,2-dibromoethane. Second option is 1,2-dibromopropane. Third option is ethyl bromide and fourth option is chloroform. The correct answer is 1,2-dibromoethane. I will show you with the help of this equation. This is 1,2-dibromoethane. When treated with alcoholic KOH, it will form acetylene. Acetylene, when it is passed through red hot tube, it will undergo trimerization to give benzene. Therefore, correct answer is first option. X is 1,2-dibromoethane. Question number 19. But2-ine plus water in presence of mercuric ion gives X. What is X? We have to find out. This is but2-ine. You are adding water in presence of mercuric. The product initially formed will be like this. Enol. This will undergo tautomerism to give butane-2-one. So the correct answer is second option, butanone. It's a ketone. Question number 20. Butane is subjected to reductive ozonolysis and you have to find out what is the product X in this reaction. When you treat it with ozone, you get an ozonide of this type. Then it is hydrolyzed and you get CH3, C double bond O, CH3. So it is butane 2,3-dione. The correct answer therefore is first option, butane 2,3-dione. Question number 21. some reactions are given in list 1 and you have to match them with list 2. A, acetylene is passed through a red hot tube. Actually here 3 moles combine to give a benzene as a product. Trimerization takes place. Next, acetylene when polymerized in presence of nickel cyanide. This will lead to tetramerization of acetylene, and the product formed is this cyclooctatetraene. Next, acetylene when passed into ammonical cuprous chloride. Ammonical cuprous chloride. You know, this will give rise to linear polymer vinyl acetylene. This is vinyl acetylene, a result of linear polymerization. And then acetylene when passed into acidified mercuric sulfate. You get acetaldehyde. You initially get vinyl alcohol which will tautomerize to give acetaldehyde. So, the correct answer is first option. That is all about alkynes. We have discussed some important multiple choice questions on alkynes. Thank you.